Hi students, hope everyone is well and everybody is rested after the break. I'm actually recording this over the break so that I have a head start on you guys. We're into chapter 6. We learned a little bit yesterday and now we're going to talk about molecular versus empirical formula. Now I'm a very math-brained person, so to me the math of chemistry makes a lot more sense than the vocabulary, the explanations. So I want to show you how molecular formula differs from empirical formula, and then we'll talk about the definition and why it's important. So hydrogen peroxide is H2O2. Whenever I see this, whenever I see formulas, I always want to reduce it to the lowest common numbers. I don't know why, it's like ingrained into me. Maybe it's my love of fractions, which I know you've probably haven't heard anybody ever say that. But when I look at this molecular formula, H2O2, I want to reduce both subscripts by 1 to get HO. And when I do that, I get the empirical formula. And what this is showing me is the lowest ratio of elements. Then in hydrogen peroxide, for every 1 hydrogen, there's 1 oxygen. For glucose, C6H12O6, the lowest common multiple between these 3 elements is 6. So I would reduce it to CH2O. So for every 1 carbon, there's 2 hydrogens and there's 1 oxygen. Look at benzene and acetylene. Benzene I want to reduce by 6, and acetylene I want to reduce by 1. When I get that, or when I reduce it for both, I get CH and CH. So when I'm looking at my empirical formula, when I'm looking at the ratio, they're both 1 carbon to 1 hydrogen, right? But acetylene is a gas and benzene is a liquid. They're very different on a molecular scale, but on an empirical, when we're looking at it, the empirical formula, it's just, they're both the same. Okay, so I'll explain to you why knowing the empirical formula is important. Some things like aniline, you can't reduce anything. You have 2 prime numbers there. And so I can't reduce the molecular formula, and the ratio is 6 carbon to 7 hydrogen to 1 nitrogen. And same with water. Water is in its lowest reduced forms. Okay, so 2 hydrogens to 1 oxygen. So I already said to you, the math makes more sense than the vocabulary, so I'm going to copy the definitions off of a Google search that I found. Look at the empirical formula. What is it that we're doing here? Well, we're reducing all the subscripts. And so the empirical formula is the formula, for a compound with the smallest whole number mole ratios of the elements. So what is this really representing? Well, the empirical formula is showing the law of definite proportions. And I'm sorry, I am a terrible writer on my iPad, okay? But is the law of definite proportions the best thing, or an empirical formula, is it useful? Well, you can see, again, benzene and acetylene, they have the same empirical formula, yet they're 2 very different things. They follow the same element ratio of 1 to 1. So why is it useful? Well, there's something called a mass spectrometer or mass spectrophotometer, which if any of you guys watch crime scene or crime shows, whatnot, you might have heard it. It's sometimes called a mass spec. And when you go to university, hopefully you'll have a chance to use it. I was able to use it a few times at my time in Guelph. But what it's going to give you is it's going to give you a readout, okay? You're going to take a gaseous entity of a mysterious substance, and you're going to have just a bunch of spikes, okay? So if it was a reading like this, over here, this is going to give you the percentage of mass, and over here, it's going to be elements. Okay, so this would be hydrogen and this would be carbon for something like benzene, or for something like acetylene. So the reason why empirical formulas are important is because this mass spectrometer, which is how we identify mystery substances, is only able to give us the empirical formula. Now, okay, maybe some of them are more sophisticated now, but it is important to learn about this. I'm not too sure about the science of it now. It's something you guys can tell me when you visit me when you're in fourth year chemistry. But for now, what the readout that we get from everything is based off of the mass spectrometer data, which gives us the empirical formula, which gives us the ratio of the elements by mass. So the molecular formula is really what is more important to us because it's able to tell us the actual identity, whether it's benzene or whether it's acetylene. So the molecular formula is the formula for a compound with the actual number of atoms of each element of the molecule, element in a molecule, or formula unit of the substance. Okay, so we're going to have to do some math to be able to figure out the molecular formula. And what's given to us from the mass spectrophotometer mass spec is the empirical formula. Okay, so here's something that, remember what I drew for you guys on the reading. This is what something might look like. Calculate the empirical formula of a compound that is 85.6% carbon and 14.4% hydrogen. So let's go through the steps. It's actually pretty easy, but the first time I show it to you, you're going to be like, why are we doing all this? But it's going to work out in the end. The first step we're going to do is assume you have a 100-gram sample. Why 100 grams? Well, because if you have 85.6% carbon, then you have 85.6 grams of carbon. Okay, and the same for hydrogen. And rather than writing it, we're trying to find the molecular formula. So I just put the numbers directly as the subscript, 14.4%. Okay. Now the second thing, and I'm just going to put it over here, is divide by the molar mass of each element. Because the empirical formula is the smallest whole number mole ratio of the elements. So it's not the mass ratio because carbon atoms weigh 12 times as much as hydrogen atoms. We want to see the mass ratio. So we're going to divide both sides, 12.01 and 1.01. So for carbon is 12.01 and hydrogen is 1.01. Okay, so unfortunately, I can't do that in my head. 85.6 divided by 12.01 is 7. I'm going to do it over here. Carbon, 7.13. And hydrogen is going to be 14.26. Okay, I'm doing 2 decimal places. And then you're probably thinking, Miss Fella, you said that this was going to give us the lowest mole ratios, and you're giving me terrible decimals. Okay, that's because this third step, you divide by the lowest number out of all three of them. So I'm going to set this up again. And oh my gosh, 14.26 is exactly twice as much as 7.13. So the empirical formula, therefore the empirical formula is C1H2. It's some sort of hydrocarbon. All right. Now, sometimes you won't get in this final step a nice number. So you need to be able to quickly convert the decimal form into the fraction form and then figure out what you're going to multiply everything by. What I mean by that is, I'm going to give you an example. Say if you're able to change everything into the fractions, okay? So say you had C5 over 6, H 2 over 3, and O 1. And you're thinking, oh my gosh, how am I going to get these numbers to, or how am I going to get this empirical formula to look like a molecular formula? Actually, this isn't even an empirical formula. What you're going to do is you're going to find the largest common denominator, so in this case 6, and you're going to multiply everything by 6. So 5 over 6 times 6 is 5. 2 over 3 times 6 is 2 times 2, so 4. And 1 times 6 is 6. Okay, and so then this is the molecular, or sorry, this would be the empirical formula. Right, so have a look at this. So again, what I did was whatever number had the largest denominator, I multiplied everything. So most of these numbers are uncommon. Most of the time you're going to see something like 0.5. So 0.5 would obviously be 1 over 2, and you're going to multiply everything by 2. You might see 0.33. That's 1/3. And so you multiply everything by 3. 0.25 is a quarter, and so you multiply everything by 4. And 0.2 is a fifth, you multiply everything by 5. Can you guess what 0.17 is? That's a sixth. Multiply everything by 6. Okay. A lot of students have a harder time with dealing with the bigger numbers. So for instance, 0.4 or 0.6 is going to be 3 over 5 or 2 over 5 respectively. So you can multiply both by 5. 0.67 is 2 over 3. The multiplier is 3. 0.75 is 3 over 4. You multiply everything by 4. And 0.8 is 4 over 5. You multiply everything by 5. Okay. So what are you were thinking, what is she talking about this multiplier? It's this big number over here. So what are you going to multiply your, the fractions by in this rough empirical formula to get the refined empirical formula here? So whenever you see some of these numbers, you are going to have to multiply the whole empirical formula by the multiplier. And sometimes you have to bump things up. So for instance, if I had 0.65 or 0.68, I'm going to put it as 0.67 and say that's 2/3. If I have 0.24, I'm going to round it to 0.25 and I'm going to say that it's a quarter. Unfortunately, chemistry is you don't get, or you're very fortunate if you get really nice numbers, but not all the time. Okay, so I think these ones here are the ones that you need to do. I don't know which one. Oh, this has to load. Come on, load. Oh, geez. Is it not going to load for me? Oh, there it goes. Okay. Let's try this one. And then example number 2, and hopefully it is one where we have to use a multiplier. So my first rule is to assume that I have a 100-gram sample. 100-gram sample. Okay. So I have C, 81.7, H, 18.3. And then my second step, I'm just going to put this here, is you divide it by the molar mass so that we get the amount. The mole ratio, so 81.7 divided by 12.01 is 6.80. And hydrogen, it's going to be 18 and change. And I get 18.12. Okay, so do you remember what the third step is? The third step is divide by lowest number. You don't have to write these steps out, but just to help you remember, I'm going to divide both of these numbers by by 6.80. So you're always going to get one entity that it's only going to be 1. And then this here, I think it's going to be 3.33. Oh, sorry, 2.66. Oh gosh, I need to go back to school. My math, it's leaving me. Okay, so a lot of students would get discouraged, or I think a lot of students would just change it into the fraction number or try to change this decimal into a fraction. Guess what? You are smarter than your calculator. You have to be able to look at this and say 2.66. That's like saying 2 2/3, right? 0.66 is close to 0.67, which is 2 2/3. So we need to have it in, is this proper or improper? I have no idea. I'll be honest, I forget the names of everything. Okay, so I have it in the fraction form, and now I can see that the largest number in my denominator is 3, so I have to multiply everything by 3, and I get C3H8. Okay, so therefore and if you want to short form empirical formula, is C3H8. That's fine. I know these are tricky, and I know everybody hates fractions. Learn to love them because they're really useful, I swear. And practice this one. I don't know if I gave you any more of these, but let's do another one. Which one looks difficult? I'm just going to do 60, okay? Hopefully this is the most difficult. I'm going to do it all in one color. Let's do the rainbow one. Okay, so again, we're going to start with assuming it's 1 gram or 100-gram sample. And I'll show you, this is going to be an answer that I expect from you guys, the level of detail, how much work you're showing me. So 69.9 divided by 12.01, I get 5.82. And then I get 6.86 divided by 1.01. What do I get? 6.79. And then oxygen is 23.3 divided by 16. I get 1.46. All right. Do you remember what the next step is? Divide by the lowest number. And I'm going to move up here. So I know that oxygen is going to be 1. 5.82 divided by 1.46 is 3.99. Ooh, 3.99. Remember I said you're smarter than your calculator. I'm going to round it to 4. And then 6.79 divided by 1.46 is 4.65. Oh God, that's so ugly. No, let's do 4.66. Okay. Why am I gave this example to you before. I said sometimes you have to round a 0.65 to a 0.66. 0.65 is, oh gosh, let's see. Is 13 over 20. It's definitely, well, maybe in the back of the book it's going to say that it did this, but I'm going to round it to 0.66. And then that means that, again, I'm dealing with 4 2/3, which is going to be 14 over 3. And so my multiplier here is my only denominator, which is 3. So I'm going to get carbon 12, hydrogen 14, oxygen 3 equals molecular formula. Oh, no, what am I saying? Empirical formula. Okay. And so that is what I'd expect from an answer, showing all of your work, just so that I can see that you are following it, the steps and whatnot correctly. Okay, hopefully this makes sense. Try the other ones out and then submit your work once you're done.